All right, so here's one from the homework. And this time we're wanting to prove that the limit goes to infinity. And so we have to use a different definition, which is here. So we're going to get really used to using our definitions and trying to use them to help us understand what our objectives are. And so this says let f of x be defined for all x not equal to a and an open interval containing a. Then we have a negative infinity limit. The limit of f of x as x approaches a is negative infinity. If for every m greater than 0, there exists a delta. Okay, so remember we're being asked up here to identify the delta. And let me just make sure that I'm sharing the screen correctly, because sometimes I forget to do that. Okay, so what values of delta are the appropriate choice? And we're saying there must exist in order for us to be able to prove this if we've chosen it such that relationship is maintained. Basically, we're saying if we choose an x or a delta so that x can get really close to a within that delta, then this thing is going to be less than some value m. So all right, what does that mean we have to do? So there's a task, right? So we will start with the relationship. We'll start with scratch work here. And we'll start with the relationship that we're interested in arriving at, which is this one here. So f of x is less than or equal to negative m. Okay, so we start off with that, and we are able to draw the delta, then we'll be able to prove this. So it's kind of working backwards. You start with a relationship that you want to show, and then you try to figure out which delta is going to make that work out. All right, so then let's see a couple of things. First of all, if I multiply both sides by -1, then I'm left with 3 over x plus 6 squared is greater than m. Okay. And then I'm gonna divide, or I guess multiply by 1 over m. Multiply by 1 over m. Multiply by 1 over m. And so I'm left with 3 over m times x plus 6 squared is greater than 1 at this point. And then I'm going to multiply both sides by m plus 6 squared, m plus 6. No, x plus 6 squared, rather. X plus 6 squared. And so I'm left with 3 over m is greater than x plus 6 squared. Taking the square root of both sides, And I'm left with, now I'm gonna bring this to this side and this to this side. So I'm gonna be left with the absolute value of x plus 6 is less than the square root of 3 over m. So now I go back to the piece that I want to start with, which is my assumptions. Now I can actually prove. So the proof, and we're not gonna necessarily finish it, would start with this relationship here, where we've chosen this to be our delta. Oops, that's not a delta. This to be our delta, which is a square root of 3 over m, but that's our delta. So we would start the proof that way. And they're not asking us to finish it, just to identify it. And so we'll go ahead and stop there.